Okay, so today's lesson is going to be on solubility, and I'm sorry for the pink hue of the paper. I'm not really quite sure why sometimes this system projects it as white and sometimes it's pink, but pink is the best color, so we're going to go with it. I'm glad that it at least chooses to be pink since I think pink is the best color. All right, so solubility. This is our lesson today, solubility. Ionic compounds are able to dissociate in water. So if I was to take table salt, which is sodium chloride, this is what you put on your food when you salt your food, and I was to put it in water, it will break down into its two ions, sodium ion and a chlorine ion, which we call chloride. Metals do not dissociate in water. So if I was to take copper and put it in water, it's just going to hang out. The copper is still going to be there. Okay, so a pure metal or a metal, a metallic substance, does not dissociate in water. Non-metals do not dissociate in water. And molecules do not tend to dissociate in water either. Well, it depends on the molecule. Let me take that back. I'm going to take that back because it depends on the molecule. Okay, so dissociate basically means to dissolve. And now in our class, we're going to talk about dissociation, and we're also later on going to look at ionization. Now we are going to learn the difference between these two, not in this particular unit, all right, but you will be learning, if you hear the word ionization, all right, that's different than dissociation. All right, a lot of times you may hear those words used interchangeably, but within this course, we are going to actually differentiate what they mean. All right, and now we know sugar, for example. When I take sugar and I put it in water, a sugar molecule has an intermolecular force within or between the second sugar molecule. There is a force of attraction holding those two particles in their solid form. So when I put this in water, we know sugar does dissolve. So I still have two individual sugar particles. But the reason they are no longer a solid is because the intermolecular force that was between them was broken when placed in water. All right. So way back in probably previous science courses, especially middle school, you heard like dissolves like. And you left it there. All right, we're not ever going to use like dissolves like because this is not descriptive enough. Trees dissolve trees. That makes no sense. Countertops dissolve countertops. That makes no sense. Soda cans dissolve soda cans. That makes no sense, right? So like dissolves like is no longer specific enough for us. I do not ever want to see that term written down on your paper as an explanation. You will receive no points if you tell me like dissolves like. Because here we go back to some crazy examples. Cars dissolve cars. Well, like is dissolving like. That makes no sense. So we need to be a little bit more descriptive. All right, so solubility is based on the polarity of the substance. A polar substance will dissolve in a polar substance. A nonpolar substance will dissolve in a nonpolar substance. Nonpolar dissolves in nonpolar. Okay? So this is what we meant that by like dissolves like. The reality is at that point in your life, you didn't have enough information to know what a polar substance was or a nonpolar substance. Now we do. So we're just going to scratch out like dissolves like, and we're going to start saying polar dissolves in polar, nonpolar dissolves in nonpolar. Okay. So let's do an example. Will water and C3H7OH dissolve when placed in a container? So what we need to do is we need to draw out the Lewis structure for each of these and determine polarity. So water, we've drawn water a gazillion times now. We know it's polar. All right. C3H7OH. Now, the order of this we've already learned determines the order in which we are going to draw it, where carbon will always go in the center. Review from a previous unit. So I have 3 carbons in the center. I have 7 oxygens around these 3 7 hydrogens around these 3 carbons. So 1, 2, 3, 4, 5, 6, 7, where these are all hydrogens. And then I have an oxygen with another hydrogen. And when we continue adding our lone pairs here, we see that oxygen does have 2 lone pairs. All right, so this substance is also polar because of the presence of this OH. All right, so when we look here, our carbons have hydrogen and oxygen around it, different substances. This becomes polar. These are both polar, so yes, it will dissolve. They will dissolve together when we place them in the same container. So when we are talking about and giving an example, will something dissolve, you have to look at its Lewis structure. You have to determine if it's polar or non-polar.